All right. Hello, everybody. Thanks for joining. Welcome to, this is going to drive me up the wall with the beeping, isn't it? So-and-so wants to join. All right, I'll have to ignore that. So welcome, everybody. Thanks for joining. Today, we're having a webinar on the current state and the future of STAPI, the spec. This time slot is actually normally a community meeting that we started last month for STAPI, and so going forward in the future, you can join that. It's open to everybody, and you can join those times. And they're usually not. It's not a webinar like this. It's more of a discussion and going through issues, and it's an opportunity for people to ask questions and that sort of thing. The presentation today is going to be an overview of what STAPI is and the current state of it, and what our plans are for the next sprint, which is going to be in Lisbon on April 1st. This is one of the reasons for the webinar, is for the people that are coming to the sprint, is so that they have the background, so that we don't have to spend the time there. But of course, it's open to the public and anybody else, so it's a great opportunity to learn about it. So I'll jump right in. I want to give a great thank you to AWS for sponsoring this year's effort for this sprint and the next one that we're going to have in the fall, and this webinar. We are looking for additional sponsors as well, so you can reach out to me, or if I haven't bugged you already about that. All right, so what is a tasking API? I think a lot of you have been to you've been to a sprint, or so you already know this, but from the top level, when we say tasking API, we don't actually mean the command and the control of the satellite. I think at one point when we were talking about this early on, somebody pointed out on Twitter or something that we're not actually tasking satellites, and that's true. We're not actually tasking the satellites. What we mean by tasking is more of the right-hand image there, where somebody is selecting an area and a time to choose to look at what images could be available in the future. It's up to a data provider to actually task that. And for some reason, at some point along the line, satellite data providers use the term tasking API for meaning this process of essentially a negotiation or an order of imagery from a data provider. The goal here really is to empower users, right? We want users to have a better experience and have it easier for people to order imagery, make it easy for people to give you money from the satellite data provider side. This process needs to be a lot easier. It's onerous in a lot of cases. Sometimes there isn't APIs from data providers. Right now, the way that we see things is that you currently have the data provider, and data is ultimately going to be delivered via some sort of catalog. We hope that it's the Stack API, but you see from this diagram, there's no connection between the user and the data provider, because that's undefined, right? It might be you have to call them on the phone. There might be some sort of bespoke API. You might have to fax them or email them. And so going forward, we would like to see this additional API here for handling this negotiation between a user and a data provider. So whereas a Stack API is for searching a archive catalog and existing data, the tasking API is for ordering data from the future. So both of these work really in conjunction with one another. A user would hit the tasking API to order data from the future. That data would then be used by, that info would be used by the data provider to place an actual task, actually do the command and control of the satellite, to get that data, process it, and eventually it goes and gets put into the Stack catalog, where the user would then hit that Stack catalog in order to do it. So these things work in conjunction with each other, and in tandem, the tasking API and the actual catalog of delivered products. So the advantage here is obvious, right? Is that with a standard API, a user can now easily consume data from all sorts of different tasking APIs and Stack APIs. And ultimately, this probably isn't even a user, right? This is some sort of ingest process by a company that is integrating data from all sorts of different places for doing analytics at large scale. I mentioned this, that they work in conjunction with one another. The tasking API really is a way to order stack from the future. This is, some of you probably heard this joke before, and so this is the last time I think I'm going to use it. I'm going to retire it after this. But I asked AI to make a Back to the Future poster, but with Stack to the Future instead, and it wouldn't do it. No matter what I tried, it said that it was copyright violations, and that it couldn't do that. So I said, okay, well, just make me a time traveling car instead, and I had no problem with that at all. So that's how I got this. But this is how we see Stack. This is how we see the STAPI is it's the stack ordering from the future. So you'll never hear that joke from me again. If we look at it in the really more general scale here, at the high level, this is similar to the diagram before, but I wanted to simplify this even more. So we've got a user, we've got STAPI, we have a Stack API, and like I said, this is like a negotiation or an ordering process where the user uses STAPI to go to the data provider, and then that data provider does something, right? In this case, it's in this case of this diagram, they're tasking the satellite itself, and that's going to a ground station, being downlinked, and some sort of process is presumably happening. Maybe it's processing it at some higher level, and then it gets put into the catalog where the user can access it. But if we think about this, the satellite and this ground station and the process is actually really abstracted, and it kind of doesn't really matter if it's a satellite or not. And so in that sense, one of the things that we kind of came to the realization of at the last sprint in Colorado was that it didn't necessarily even have to be a satellite. A user uses STAPI to order some sort of data from the future, or some data that doesn't actually yet exist. And then something happens, some sort of processing workflow. This is an asynchronous process. That data could actually exist. So this could be ordering some product. That workflow on the other side could actually be a third-party call to another satellite company. Like if this is a downstream analytics company that's adding some sort of value, creating some sort of derived product, STAPI could be used in that case as well. So I do want to be careful about trying to shoehorn a lot of different use cases into this, but this really did seem to make a lot of sense. In that STAPI is really, in this case, it's really about ordering data that doesn't yet exist, if we want to just think about it in more of those general terms. I'm going to take a brief diverge a little bit here and just talk about Gorilla Standards, because I want to talk about how we approach this whole process and sort of why we're doing this and why we're developing a spec to begin with. I stole this term Gorilla Standards from Howard Butler, and I want to talk about the difference between specifications and standards. You'll notice sometimes maybe that I try and be careful to not use the term standard when we're talking about STAPI or even about Stack. Stack is called the specification. A standard is really developed by a standards body. Okay, we are not a standards body. We're a community, right? Standards are super useful. There's great need for standards in the world, but it's a slow process. But they do have an established governance and detailed requirements. There's usually a rigorous review involved. There's uniformity across multiple standards, and they're really good for large projects where there's lots of people that need to develop this standard. Think about like hardware standards, right? USB, like these are clearly very important. Specifications, on the other hand, are developed by a community. It's a fast process. We can get together and we can really focus on interoperability and how we want to be interoperable. There's not necessarily a dedicated governance. It's open source. It's transparent. Much more transparent typically than a lot of standards is, because not everybody can get involved with standards because they tend to be a lot bigger. We want to focus on the minimal specification and focus on grassroots adoption. They're really good for small projects. One major difference here is that standards often require adoption is required when you have standards body through regulation. And what we're doing is not that, right? We're not regulating people. We don't have any authority to regulate people to use a standard. We focus on this grassroots adoption and focus on getting people to adopt the specification because it improves the interoperability. It makes their job easier. It saves time. It gives them open source tooling to use, and it helps make it easier for customers to order data from them. So how do we go about building this community standard or specification? Well, first off is you need to build a community. So this clearly has come out of the lessons learned from STAC. This is why we're doing it this way, because this was a process for STAC, and that apparently has been somewhat successful. So the first step is to really build this community. So this is about gathering stakeholders, getting the right people in the room that are going to use this, they're going to implement it, and promoting ownership among that group. Companies really don't give. They don't care about standards, right? They only care about standards when they're told that they have to use them and that they have to implement them. So a big government agency might say, well, you have to implement this because we're not going to order data from you otherwise. And so they don't really care. So what we want to do is promote a sense of ownership among users in the community so that they're implementing this and adopting it because it makes sense for their business, not necessarily just because they're told that they have to. Of course, we want to leverage existing standards to make this adoption easier. And so in this case, GeoJSON, we build upon the paradigm of OGC APIs of using conformance classes. We're using CQL2 rather than developing our own query language for using this. Of course, it's a REST API. And STAC, we're closely aligned with because we see that ultimately data is delivered in a stack format when it's ordered through the tasking API. Developing the open source implementations, the ecosystem as we call it, is super critical to this because one way to drive adoption is to have tooling that people can use so that they can see how this works. But developing the ecosystem also serves another really important purpose, which is that it can help inform the development of the spec. And so this is an iterative process where you develop implementations, you develop software, you see how this works, and then you iterate on that, and that can help back inform the spec. A side effect of this is not necessarily desirable, is that sometimes the implementations, I would say often, we saw this in STAC a lot, is the implementations actually lead the spec, where people try things out in the spec and within an implementation itself, and then it kind of gets ahead of it. And it's like, oh, well, we had this thing, we had this idea, we tested it out, and it's in the software, it's in the open source ecosystem, but we actually didn't update the spec yet. And so we're in that case now where we have an implementation where some things are in the implementation, but we have to feed back those lessons learned into the spec. And then outreach. Like outreach is super critical, like getting out there. And so with STAC, a lot of us were out there talking at conferences regularly and giving webinars and tutorials and that sort of thing. And that's super critical. So really would encourage you, if you're using STAPI and you have the opportunity to talk about it, please do so. That is a really great thing to do for the community. So how do we measure success? Or put another way, like how do we know when we're done? Or how do we know when we get to a version 1? Well, the first step is adoption, right? Like that's like perhaps the most important criteria. In fact, it's the only criteria. This is really all about adoption. It's the only thing, I argue that it's really the only thing that matters. I mean, you could argue that the spec needs to be good. That could be a metric for success, but if people are adopting it, then and they have a feedback loop into the process and they're involved in the process and they're adopting it, then I'd still say that that's the only metric that you really need. It's the most important thing. A standard that is not adopted is really not useful for anybody. So to summarize here, we have this loop, this cycle of life here for developing a spec. Spec development feeds into implementations, and implementations feed into developing standalone software tools, modular software tools, which feed back into the spec. We've got open source contributors that are contributing these software tools, and data providers working on implementations. And these community stakeholders all feed into this development. Okay, so the story so far, I think that Trevor is taking over for this one, right?
Yeah, absolutely. So thanks, Matt, for the kind of the background and where the standard came from. We kind of identified this as something that we were wanting to work on. So back in 2022, we had this idea that SAT Summit was coming along. We would have a lot of the right people in the right city. So we decided to host the inaugural version of this. We didn't have a name. We just called it the 2020 Tasking Sprint, just more of a kind of a research or groundwork piece to just like, let's figure out what the problems are. Let's figure out if there's already a common solution that we can leverage for this. And so we invited everyone to our headquarters in Alexandria. We had big hopes of, coming out with some code and some tools and some, let's call them deliverables. We didn't quite get that far. It was a very vigorous 8 to 10 hour day of primarily arguing with each other about the definitions of words, which if you've ever been involved with any kind of spec or standard, that's pretty much par for the course. We should have known better. But it was great. We knew there was enough interest, there was enough enthusiasm, there was definitely enough need. As we'll show later on the slide of all the people that have come along, we had a really wide network of partners helping us on this very first day, which kind of set the tone. We had data providers, we had data processors, we had data resellers, and all across the spectrum, including organizations like Element 84 that kind of do implementations around data tooling and data processing. So we kind of coming out of that, we're like, hey, we need to do this again, see if we can make a little more progress. So in spring of 2023, we hosted at our other headquarters in Philadelphia. This was a 2-day sprint. We were able to make a lot more headway itself on actually documenting the spec. We got it kind of refined down to the major endpoints, which at a high level have kind of, we'll get into those a little bit later, but at a high level have stayed since that initial discussion. They've gathered some branches and some specificity along the way, but the 3 main endpoints have existed since kind of this second sprint. Can you go to the next slide, Matt? And at that point, we realized we might have had a little bit of a America-centric view in that we really didn't have any collaborators from outside of relatively basically the East Coast, with the exception of one West Coast organization that had been a partner since the beginning. And so we decided to take the road show over to Berlin last year. This was probably, I think it was our biggest sprint, and it was a great event. It brought a bunch of different types of data providers as well as different business models. Data sales, I mean, it's still selling pixels, but the way you interact with your customers, the regulations, the structure of how those contracts really can have an implication of how the spec should look. But we had a great Up42 was our host in Berlin. This was actually a 3-day sprint, and that's when we kind of moved to this 3-day method, especially on the larger ones. And we were able to, Matthias, I think, is here, with the help of Matthias in person, really start to actually get some code developed. I'm seeing Christian on the call as well. He helped on part of our implementation team. And coming out of this, we actually had some real life proof, which I'll show you the examples after this slide, of this thing functioning for data providers and in real world data situations. Again, we really want to make sure that we're including as wide of a net as we can. So it's still really nice to have folks that are on the business development or sales channels. I think that's actually really helped us make sure that we're not just developing an engineering solution, which is a tendency that we can have working in these types of projects where we want the tool that is optimized for us as developers. Skipping around. After that, later in the year, I think that was, the Berlin was in the spring. In the fall, we went out to Denver. NV5 hosted us out there. This was kind of the American version, and it was more about getting down to brass tacks and implementations with some of the providers that were there. You can see us working very hard. If anybody knows Andy Finkmiller right there, he was actually one of the successful groups coming out of this. So go to the next slide. here are all the organizations that have at least contributed to one sprint. They might have been sponsors, but have all been interested in this subject. So you can see kind of the wide breadth, a lot of data providers, analytics organizations, like people like ourselves. You also have OGC has come along as a sponsor. They're obviously interested in these types of standards and have been contributors as well. Umbra, all great organizations that have really come along. You can kind of see that width of groups. So go to the next slide. So this is really where we started to get better documentation. So everything that we've done coming out of the Berlin sprint, like I alluded to, was like a documentation heavy sprint, has now been put up into the open source repository. Again, emphasis on this all being a collaborative effort, open and freely available, as well as that's where you can ask questions, put up issues, get those resolved as part of what our sprints, and we'll talk about kind of what our objectives are for Lisbon coming up. But ahead of time, we encourage people to go in there, ask the questions, get their issues logged into the repo so that we can actually go through, curate those, answer them, as well as integrate the solutions. But all the resources are available on GitHub. And now let's get into the actual implementations that we were able to achieve. So this is one coming out of the Berlin tasking sprint. We actually kind of built this UI during the sprint. We had front-end developers. I think I saw Jessica on this call here. She was there helping out. We had the UI folks in one room. We had to kind of quarantine them to actually not be in the hubbub of the main room where we're talking theory and standards and spec. So we were able to actually
techno music that was played during.
I believe, yeah, I think it was European on brand. So we really had to get the techno music going in there. So we came out with this UI, and this is actually looking directly at some Umbra data sets. But it kind of is just starting to exemplify the fact you see at the top where we have the dates up in the upper right-hand corner. You have the geographic space where you see the polygon. And on the left-hand side, you start to see some of the idea of filtering and how this idea of constraints that we'll get a little bit more into starts to work. But this is a real implementation that was querying a real catalog of data and allowed us to look and see. And this is the first time that it quote unquote worked. Go ahead to the next slide. And here's where you can kind of see some of those constraints. So you can see we're able to like look at scenes with target azimuth. And these are all configurable per data provider. So these are not set, similar to Stack, because you kind of have this flexible metadata scheme that allows you to specify what you think is important about your data. As we continue down this path, we'll probably have these kind of standard kits like they do for Stack, which are these extensions. Go ahead to the next slide. So that was Berlin. And then this was actually in our Denver or our Colorado sprint. This was actually the first time we legitimately ordered data with the STAPI sprint. So the previous ones had looked at archives and were able to kind of look at historical data using the same principle. And in theory, kind of projecting forward what would be possible to order. We used Sentinel for one of the examples. This was literally ordering data. Specifically, this scene was ordered, purchased, eventually processed, and distributed to our team. So this was a great example of actually an implementation all the way to the end. And this was Umbra within their Canopy, Canopy platform. So from that first day of just arguing and really defining terms, within a couple of sprints, we're actually to a real live implementation where it can actually send the information, a user can interact with it, and you can get what you need from Stack to the future, as I believe Matt likes to say. It's awesome. Next slide. I think it popped back out. There we go. And I think I'm going back to Matt.
Yes. All right. Thanks, Trevor. All right. So the specification. Okay, so I'm going to kind of speed through some of this. It's not going to like go right into like a whole lot of detail, but it should give you a flavor for sort of roughly how the spec works. So within STAPI, we've got 3 different entities. We've got products, opportunities, and orders. So a product is something that is defined by the satellite vendor. So it's a pretty flexible concept. Like for instance, multispectral data might be a product. SLC SAR data might be a product. A gamma naught SAR might be a product, indicating that like it's not just collected, but it's also processed into some downstream product. So stereo imagery, as on the previous example for Black Sky, had stereo imagery as a product. So the vendor really is defining all of the parameters that can be used for ordering that product. We call these parameters constraints. You can think of these like queryable, except you're not querying data that exists, right? It gives you this is ultimately ends up what you're ordering, right? And so when you use the opportunity, an opportunity is for a single product, and it's a description of data that may be collected in the future. The difference between an opportunity and actually realized data is that with opportunities, there are often ranges involved. So like the date, you don't know the exact data to collect. You might not know the exact collection angles, but you might have the range of what those are. So opportunities are a cloud. You can think of it as a probability cloud of possibilities. And when you order a product, you have constraints on that. And when you get back the opportunities, these are the ranges of possibilities given those constraints. An order is actually when you're ready to order the data. That's pretty self-explanatory. That's you're ready to purchase it, and you put in that request. And then that state changes from order to ultimately delivered or not delivered, not fulfilled, which, as we all know, could be a variety of reasons why that might happen. The list of endpoints here, you'll see, I'm not going to go through every one of these, but you'll see it right up at the top. There's a conformance endpoint. I mentioned before we use conformance classes and OGC APIs, so that's a good thing to read up on if you want to learn more. Is just how conformance classes work. It's a way to advertise capabilities for the API. It's essentially a description. If you're familiar with old OGC APIs, they're called get capabilities, is the equivalent there. But this is how a client knows what is and what isn't supported. For instance, your tasking API might support point-only requests, or they might support polygon requests. And the way that you know that is through the list of conformance classes in the API. We have the products endpoints, and you'll see that opportunities and orders are per product. There isn't a high-level opportunities, but there is a top-level order status, so that you can get your list of all your orders, regardless of the product, and see the statuses. All right, so this diagram might have been useful 2 slides ago here first, but the general overall workflow here is the user hits the product endpoint and sees what sorts of products are available. They would choose one of these products and then hit the opportunities endpoint with a request, including spatial and temporal information at a minimum. So this area for this time period, and they get back a list of opportunities. They can then sort these opportunities, and then for a given opportunity, there's a link to order. And I'll talk more about the sort of difference between opportunities and orders, and then you get back the order object. Now, it's important to note that opportunities actually aren't strictly required. They're not required as part of the implementation for a STAPI API. You can just get a list. You could just, given a product, you can actually just place an order directly. So you would say this period of time for next week. The concept of opportunities are flexible, and that was the intention, was that we have found that different data providers have different business models. And in some cases, a data provider might take in a request and give you several opportunities back, but they don't have to. They don't have to actually partition your request into multiple different opportunities. They could just return one. So if you say, for instance, I want this area for next week, they could actually return an opportunity that is for the entire week. But they wouldn't have to, and maybe they return 3 different opportunities on 3 different days within that week. And so the specification can really handle both of those cases, and it's up to the provider on what sort of level of granularity it is that they want to provide to the users. This is a description of the product. You can get this from the repo. This is JSON. You'll notice this looks very similar to a stack collection. It is very similar. The opportunity requests and the create order requests, you'll notice I said that you don't have to go to the opportunity. These requests are very, very similar. They take in a datetime and geometry and a filter of CQL to JSON, which allows you to filter on these constraints or order parameters. There is one significant difference between an opportunity and an order, and that is, here's an example of the constraints here. This is a product definition that is defining what those constraints are and like what the minimum and maximum. Essentially, they're providing the schema for each of the constraints that are available. And now, so the difference between, I'm backing up here, difference between a opportunity and an order in the creation of it is that on opportunities and orders, you have constraints. These are limitations on the actual collection of the data, right? Like this is like angle collection or some sort of parameter that changes the collection and potentially changes the opportunities that are available. But we also have order parameters. So these are things such as what data format do I want, or where I want you to deliver the data. And these are order parameters. They're not important for an opportunity because they're not going to actually affect what opportunities are available, but they will change the end product. And so constraints you would supply to both opportunities and an order, but the order parameters only apply to actually orders when you're talking about an ultimate delivery of that data. An opportunity object is a GeoJSON. You'll see this looks very similar to a entities in Stack. And the order object, this is there's been a lot of discussion around this order object recently, and I think that we're really leaning towards making this GeoJSON as well. And so an order object, when you look at your list of orders, you actually have the full geometry in there rather than this more bare bones description here. Okay, I got one slide on the ecosystem, and I'm going to hand this over to Preston. But right now, if you look at this organization, you'll see that there's some core STAPI repos there, as well as several provider implementations. These are in various states of completedness, or in some cases, just a skeleton. And it's going to be one of the focuses of the sprint. And now I'm going to hand this over to Preston to talk a little bit about the most important implementation and the most developed implementation right now, which is STAPI Fast API.
Thanks, Matt. I'm actually going to defer to Phil Varner, who is also very involved in the development of the STAPI Fast API library, to explain a bit more about what STAPI Fast API is and how to use it.
Okay. All right, great. All right, so Phil.
Hi, I'm Phil Varner. I'm also associated with Element 84, and I'm currently working on a orders implementation for one of our customers, and we're using STAPI Fast API for that. So I'm going to talk a little bit about the internals of that implementation and how that relates to the specification that Matt just talked about. Next slide. Yeah, so STAPI Fast API is a Python Fast API web API implementation. It breaks down most of these endpoints into a couple of different types of objects that Fast API uses called routers. We have a root router to handle many of the endpoints that are not specific to a product, including the conformance endpoints, products endpoint, placing an order, and getting the order status. And all of these are nicely connected using link relations, so that you can use a HateOAS style of navigation of these various links within web application or any other type of application that uses this API. Each product has a product definition and a product router associated with it, so that it can define specifically for that product the constraints that a user can filter based on, the order parameters that apply when placing an order, and the actual mechanism of placing an order and validation and that sort of thing. And additionally, the opportunities endpoint can be specified per product also. Next slide. Yeah, so the STAPI Fast API in construction is a little bit different than some of the Stack API server implementations, because the Stack API server implementations primarily search and interoperate with a very uniform set of data, and it's typically stored in a database of some sort, whether that's Postgres, Elasticsearch, something like that, and do queries against that. There's some configuration that needs to be done in the server to describe the data some, and there's a few settings there. STAPI Fast API is quite a bit different, because instead of just searching over items that are already in a database, it is really intended to hook into any system that a satellite provider has created that can predict what they could task in the future. And so this could be as simple as, you can order anything and maybe we'll be able to collect it, maybe not, to being able to have a very precise orbital dynamics model to predict when the satellites are going to be in specific places and what the various angles associated with collecting different places on the Earth would be, and giving the user a really accurate model about what could be collected when conforming to that user's desire in terms of place, time, angles, all the other different attributes. So because of that flexibility, a lot of the actual implementation of it has to be pushed out of this generic framework for the API and into a customer or a provider's specific implementation. So that's one of the things we've attempted to do in this implementation is have these hooks in, so that a provider can have a specific implementation of the logic and behavior that they need. Okay, so the first thing we do is we define a product. Next slide. And this is the code that would be done with that. We have a few obvious things like an ID for it, a title, a description, license, these various things that just describe what that product's attributes are. And then the next thing we do is we actually provide implementation of various behaviors that product needs. So the first one we have here is create order. And so that gets passed a function or a method that's implemented that has several parameters that it takes, a value that it returns, and the expectation is that a provider who's implementing this would then have their specific logic for what happens when an order gets created. And that may be inserting it into a database, calling some other system to say, I've got this order, I need to actually cause the satellite to do something in our tasking system. And then we have a few other methods like that. A method that can search an opportunity, and a method that can search an opportunity asynchronously in case that you want to have a interaction method where a user can submit their request for the opportunities you can go off and do whatever you need to do to determine whether that can be fulfilled and what opportunities are available, and then it can be returned to the user asynchronously. And likewise, similar things with the opportunities themselves. In a lot of implementations, the opportunities, as Matt mentioned earlier, the opportunities search won't actually be implemented, and only the create order would be implemented. So this gives some flexibility around that. And then additionally, each product defines the constraints, the terms that can be used when filtering the opportunities, and other the opportunity properties and the order parameters that can be associated with that order. So that's flexible in STAPI Fast API at the product level. Next slide. Yeah, so here we're showing what a constraints model. Fast API uses pydantic models for just about everything. Here we've defined a model that defines the constraints on this product, and we say that there's a value that a user can define, saying that they can provide an off-nadir value, and it's an integer, so that a user could say, well, when it gets collected, I only want I want a maximum of 10 degrees off nadir, and the provider can reduce the set of opportunities that it could return from that. And likewise, when the provider does return those opportunity properties, instead of returning a single value, it would probably be returning a range of values, which this model allows that opportunity to express. So if a user searches on, they want a maximum of 10 degrees, the opportunity may say, I'm not sure exactly what the angle is going to be, but I know that it's going to be between 5 and 7 degrees. And that can be expressed in that opportunity, and the end user can make a decision as to whether they want to take that opportunity and order it. Next slide. Okay, so now we're going to show how to create the route router object and add a product to that. Next slide. So we define this route router with some other methods that have type definitions on them, a method to get orders, to get order statuses, to do an opportunity search. You can imagine that get orders and the get orders methods, those would call into a database and retrieve some objects from there. And likewise, these opportunity search records may call out to another service. They may have an internal model, but they're flexible, and the opportunity search ones are optional. So user can implement them or not. Likewise, we have a number of conformance classes that are advertised in the API, so that a consumer of the API knows what behaviors are supported. And so in this example, we have conformance classes for opportunities and async opportunities. So a client would know whether they have to do opportunity search synchronously, or they have the defined asynchronous opportunity search. Then the product is definition that we saw previously is simply added to that route router, and that router is included in the Fast API app. And that's the primary wiring of all of this together. Next slide. And one of the nice benefits of using Fast API is everything is very well defined, and it allows Fast API to automatically generate an open API definition and an open API UI that advertises all the routes and type definitions for all the endpoints that it supports. And I think that's the last slide in this.
All right, awesome. Thank you, Phil. All right, the last few slides here are going to talk about what it is that we want to focus on in the next sprint. So again, I want to call out AWS here and also Development Seed for hosting this in Lisbon. Appreciate both of them, and looking forward to going there at the beginning of the next month. So the big thing, one of the big things, of course, is discussion around the spec. There are several ongoing discussions within the repo. I put links in here. So one of those is kind of solidifying conformance classes. I mean, I think that's mostly in place, talking about what's core versus what's optional, and getting to some final decisions there. Another thing that has come up is this idea of archive ordering versus tasking. So Umbra, in the previous slide, you notice that they were actually using in one of the GUI examples that they had successfully demonstrated using STAPI to order data from an archive. That was not an original intention of STAPI, but it did work. But there is some issues around that, and I think there's some discussion. So there's an issue there where some of those discussions have happened, and it's something that we need to talk more about at the next sprint. Also, it sounds like, looking at all this, it sounds like we have things pretty well defined on what things mean, but that's actually not the case. There is still some ongoing discussions about what exactly an opportunity is. Every company is using different terminology for things. There's tasks, there's collects, there's opportunities. Is an opportunity actually a single collect, a single look? Is there multiple opportunities that can be used to fulfill an order? Coming to some sort of consensus around exactly what all of these things mean and getting that documented is important. Async opportunities. This is actually implemented partially, at least. I don't know, I could be wrong, but it's partially implemented, but the spec has not been updated for that, and there's some open questions around there. And same thing with the CQL2 filtering, is that there are some open questions around that. And so all of these are open issues that hopefully we will be able to resolve and come to a conclusion on. So that will be one of the big focuses. In this sprint, we really want to get to an actual release, a 0.1 release. We actually haven't put out an official release, and so this would be a great thing to do in the next sprint, but we don't want to release something where there's mismatch in between documentation and everything. And so there's a bunch of housekeeping to do here, making sure that all the examples are correct, getting the spec up to date with the actual changes in the implementation that we made and decided on. There's several open PRs. We want the open API documentation to be accurate, and then the process of actually cutting a release of the spec and having that open API documentation hosted somewhere that can be easily accessed and be consistent and versioned. The other focus here is on the ecosystem, of course, which we've talked a lot about. And I showed before that there are several repos up there. We want to refactor the existing STAPI Fast API repo. Right now, it contains all of the data models for these entities. And we want to use those in other libraries as well. So we want to split things out into some multiple packages. So if you're familiar with the Stack ecosystem, you'll notice some similarities here. PyStapi would be the sort of core library that defines all of the data models that Stapi uses. And then there's PyStapi Fast API, which is just going to use that library. And then PyStapi Client, which would be for consumers to use to query, find, and help them automate a system to be able to place orders and actually take delivery of that. There's an open issue there that talks about this splitting up and putting these things into these multiple packages. And then the other focus is actually building some API implementation. So we would love more and more data providers to use their existing tasking APIs if they have them, to develop a proxy. You can use STAPI Fast API for that. Several folks have done so, or at least gotten started on that, is developing a proxy so that your back end is actually just querying and using your existing tasking API and then mapping and translating those results back to STAPI format. For providers who don't yet have a tasking API, well, then this is a great opportunity to get a prototype working for them. There's a TLE backend, which would be great to get to a prototype implementation that could be demonstrated. That I think it mostly worked last time, but now some things have been broken because that's the nature of this work, is that you develop something and then the spec changes and then everything breaks and you got to do it again. And so the TLE backend is something that would just where you'd be able to use access any sort of two-line element file to describe an orbit to get an opportunities for any satellite for which you can get the TLE for, which most of those are public, if not all of them, I don't know. And then having a Landsat or Sentinel-2 has long been sort of a stretch goal that we start on, but never quite have not gotten to a complete end-to-end implementation. I see this as a great opportunity. Of course, Landsat and Sentinel-2 are not tasked instruments, but you could treat them and pretend like they are, where a user could at least see how the process works and look at opportunities. So what are my opportunities in the future for Landsat or a Sentinel-2? And then actually placing an order and showing how the order ultimately would be fulfilled once that data is collected. So that's just a great proof of concept and something that could be an open demonstration that could be publicly available for people to use so they can really see how the tasking API would work. And then also a validation library, which is usually one of the last things that anybody wants to work on, but it's actually super critical. So hope somebody will step up and work on that. And that's it. Thank you very much. We went a little bit over time and don't have a ton of time for questions, but we got some time. And also remember, this is a community meetup at this date and time every 2 weeks. So you can always join or you can participate in on the discussions on the repository. All right. Some questions? Comments?
We did a fantastic job of describing everything perfectly, Matt, it appears.
Awesome. Jessica. Okay, so UI development. Well, I think that's to be determined. It depends on, a lot of these sprints, it kind of depends on who shows up and what people want to work on. And so the last thing we want to do is have a bunch of people show up that are like UI developers and say, okay, you're doing back-end development. Like that's right. If there are folks doing UI and want to do UI, that would be fantastic.
Yeah.
We have started that. We have a UI. We didn't do it at the last sprint in Colorado only because we didn't have any UI people at that one.
Volunteer as tribute.
What's that?
I volunteer as tribute.
And,
okay. All right.
And
awesome.
also, I know at least have the two UC guys that were helping you last time.
Yeah. Sweet.
Rachel will not be there, unfortunately, so you'll
Bummer.
have to supply your own techno music, but I think we can.
Yeah.
Excellent.
So there will be some UI people there. So that would be great. I mean, I'd love the UI because it's great for demonstrating it. Like it's really kind of hard to demo a back end.
Yeah.
Most people don't find that very interesting. So, and yes, the recording will be published. Sarah will get that up on our side and send out a link to the group. And I think it will just be publicly available. Sarah, is that right?
Yeah, that's the plan.
Okay.
We can send it around and make it whoever wants to watch it can watch it.
All right, awesome.
Yeah, I think we're going to make the slide deck available publicly as well as a PDF. So
yeah.
Also, the plan is to send out a survey after this just to get some feedback on everyone's thoughts on the webinar, and that'll go out through whatever email you use to sign up for this. And that would be really helpful if you could fill it out just so that we have a idea of what was helpful and what we could add more information about for a future webinar like this.
All right. Do we have any more other questions or comments? Okay.
If not, thanks. I think we just want to thank everyone for attending. The intention of this was for first-time folks who are coming to the sprint to kind of learn a little bit more. Additionally, if you're not a first time, it's just kind of a reminder of what we've done before. If you've missed a sprint, that's kind of the format. So as you're filling out that feedback survey we're sending out, keep that in kind of mind. Let us know how, if you're of different audiences, how it might be better or worse. Our intention is to continue to do these going forward in preparation for the sprints, because if you've been to one, this is kind of that first day, that first initial. We'll do a truncated version still, but really to start making sure we can get more into the meat of the subject every time. So thanks everyone for attending, and Matt, I'll give you the last word.
Yeah, thanks so much. If you're coming to Lisbon for the sprint, then look forward to working with you. And otherwise, please join the community meetups. And also, just to reiterate, also we are looking for additional sponsors, so I might be bugging you about that as well. So thank you, and please reach out if you have any questions or want to talk more. Bye-bye.
See y'all.